Good morning, and welcome once again to another episode of the Angry Astronaut. As I reflect upon my channel today, it occurs to me that I have a lot to be grateful for. I've just exceeded 1,500 subscribers. In the space of a few days, I've added hundreds of new people to my family, and I am so grateful to all of you. Thank you so much. In addition to that, I have something very big coming up, but I'm not going to announce it just yet. Instead, I'm going to leave that to my partners at my favorite space channel, and yes, that includes my own, which I will have linked in the description. You can follow that and keep your ears open for an announcement coming very soon about something very big and something I'm very excited about. Tons of things to be happy about, and yet I am still pissed. And I'm not pissed about the fact that I'm still using this Bluetooth thing, although with following the advice of some of my subscribers, I brought in some things to absorb sound into this room. I have no idea if that's going to help it or not, but best of luck, I hope. In any event, it has nothing to do with that. It's the fact that if you go online, you can find dozens, if not hundreds of articles about the dangers of Martian radiation, the dangers of radiation to Mars colonists. It is the only major thing that's seriously discussed, aside, of course, from the obvious things that there's nothing to breathe and it's extremely cold. But radiation. And a lot of you have already seen a video of mine, which I also have linked in the description, that covers that particular subject. But everybody seems obsessed with that. Something that has a 5% chance of killing you if you stand unexposed on the Martian, or rather unprotected on the Martian surface for 8 years, something along those lines. I mean, really, is that the most significant thing we have to worry about? What bothers me a hell of a lot more are the dangers that we don't know a lot about. For example, landslides. We know they exist. We know they happen on Mars. I'm going to show you a very good image of one here in a minute. We know they happen, and yet, are they a significant danger to colonists? You go online, look it up, you'll find virtually nothing on the topic. Well, that's what I'm going to cover today. What nobody else seems to want to cover. 3 different major threats to Martian colonization that nobody seems to talk about. And I'm going to start on that right now. This astonishing photograph of a Martian landslide was taken by the Mars Reconnaissance rover by pure chance just as it passed over the planet's north pole. Absolutely stunning. And it managed to get it from several different angles. And even though this was a relatively small landslide, it's still extremely impressive. Those cliffs are 700 meters high, or twice the height of the Empire State Building. And as you can see, the devastation went on quite some distance from the cliffs themselves. Now, it was previously thought that Mars is geologically dead, and so these sorts of avalanches could only occur at the poles when the warming temperatures during the spring would melt and evaporate the ice and create these sorts of occurrences. But since the Mars InSight lander set down on the planet in 2018, hundreds of Marsquakes have been detected. And that could be very, very bad news, because much, much larger landslides have happened in Mars's past, especially in the Valles Marineris. Now, as many of you know, this is the largest canyon in the solar system, and as you can see from this map, the extent of the devastation of some of these landslides is truly stunning. It sent billions of tons of debris at speeds of hundreds of kilometers per hour down into the canyon, a system, as you can see here, that is quite vast when superimposed over a map of the United States. But the reason the area affected by these landslides was so huge and the speed of the debris was so fast was because of the unbelievable height of the canyon walls. 8 kilometers as opposed to 1.7 from the Grand Canyon, as you can see here. And so when the landslide started at such an unbelievable height, the speed of the debris and the area affected is truly beyond our comprehension. Some of these landslides wiped out an area as large as Rhode Island. Could something like this happen today? Well, the planet is still geologically active and the canyon walls are as high as they ever were, so this is a threat that we should take very seriously, especially if we explore the Valles Marineris. No, I'm not a conspiracy theorist who thinks that this seasonal cloud of ice and dust from Arsia Mons is an eruption, but there's an increasing number of scientific experts and geologists who believe that Mars may still be volcanically active, as pictures like these seem to indicate. Now on Mars, whenever you get such obviously volcanic formations like these that aren't marked by any sort of impact craters, it indicates that the volcano formed fairly recently, within the last couple million years at least, or perhaps even within the last few 100,000. Now that may sound like a long time, but it's just a tick on the clock as far as geology is concerned. Now, these sorts of volcanic formations and fairly recent-looking lava flows are all over Mars, strongly suggesting that the planet may still be volcanically active, especially if you compare these formations to similar ones on the Moon that are obviously pockmarked with craters and other debris indicating that they haven't been active for a long time. And adding to this is the fact that a large lake of liquid water has been discovered beneath Mars' south pole, and the only way that this could be kept in a liquid state, at least according to current theories, is if there's a hot magma chamber directly beneath the lake, keeping it warm and in a liquid form. And of course, where there's large magma chambers, there can also be active volcanoes. Now, of course, no one's actually seen a volcano erupt on Mars yet, but that doesn't mean one won't erupt in the near future. And where there's Mars quakes and where there's magma chambers, there could very well be a volcanic eruption. And with volcanic eruptions comes, at the very least, powerful earthquakes, which could damage habitation structures and cause critical damage to their life support systems. Now, given this planet's violent volcanic past, and also given the fact that we're thinking about setting up cities in lava tubes, or at least dwellings in subsurface environments, it'd probably be a damn good idea for us to get a better notion of how this planet's geology works before we decide where to settle. Of course, probably one of the best ways to understand this planet's geology would be an in-depth study and survey of the Valles Marineris. An incredibly deep canyon like this would provide you just about all the information you needed about this planet's geological past. You remember the Valles Marineris, the one with the 8-kilometer high valley walls and the ridiculously huge landslides the size of Rhode Island? Yeah, that canyon. But perhaps the greatest threat to any future Martian colony is one that may not exist at all, but then again, one that could be lying in wait for us all over the planet. one that has the potential, if it does exist, to completely wipe out a future Martian colony. And that, of course, is number 3 on our list: Martian microbiology. Now, of course, the very existence of Martian microbes and their threat to the human species is hotly debated, but it's got this guy so scared that he thinks that we should not go to Mars at all. And not only that we shouldn't even return any materials from the surface for fear of wiping out the human population in a global pandemic. Now, this isn't just some random crackpot. He's Dr. Gilbert Levin, who way back in 1976 was in charge of the experiments designed specifically to detect life on the Viking spacecraft. Now, this experiment would introduce a number of elements, especially oxygen, into the Martian soil to see if anything would metabolize it. And to the surprise of the researchers, something did at both the Viking 1 and Viking 2 locations. And by the way, this test had never produced a false positive back on Earth. Not only that, when the soil samples were heated, they would metabolize the oxygen at a much slower rate, as would be expected if there was something alive in the soil. So why don't our history books tell us that life was discovered on Mars back in 1976? Well, because a second test was introduced to search for organic molecules, and that one came up negative. And since you need organic molecules in order to have life, there must have been something else consuming the oxygen besides something being alive, or at least that was the conclusion at the time. But Dr. Levin was insistent. His experiments had never produced a false positive and produced the same results at both Viking locations, even though they were 4,000 miles apart. Perhaps it was the instruments detecting organic molecules that were wrong. So fast forward to 2012, when the Curiosity rover landed on the surface of the Red Planet to prove so many things that we thought were true about this mysterious world to be absolutely incorrect. For example, radiation levels, which proved to be much lower at the surface than we thought they were. I bring that one up just because it pisses me off so much, but let's not talk about that right now. Now, even though this rover was not supposed to be looking for life, it did have one experiment to look for organic molecules, and lo and behold, it found them. Now, how could this have been possible if the Viking experiments found no organic molecules? Well, because they weren't present in a large enough quantity in terms of parts per million to produce a positive result in the Viking experiments. The instruments weren't sensitive enough, but the Curiosity instruments were. Now, in 1976, if Viking's instruments had turned up the presence of organic molecules as Curiosity's did later on, this Gilbert Levin's claims probably wouldn't even be questioned today. And these aren't the only things about Mars that strongly indicate the presence of life. First of all, why is the Martian atmosphere comprised of carbon dioxide at all? As Dr. Levin points out, this atmosphere has been under constant bombardment from cosmic rays and should have been converted into carbon monoxide unless there was something metabolizing oxygen and converting it into carbon dioxide, namely something alive. In addition, there is an unusually large amount of methane in the Martian atmosphere, so much so that Elon Musk wants to use it for his Raptor rockets. Now, the high presence of methane probably means one of two things: either that there's something alive on the planet producing it, or that the planet is a lot more volcanically active than we thought. Neither one of these things would be particularly good for future Martian colonists. And finally, we have also found far more liquid water and oxygen on this planet than we ever dreamed was present. As a matter of fact, the liquid water could actually support not only microbial life, but also simple organisms like sea sponges. And the oxygen being present, perhaps being metabolized into CO2, seems extremely obvious to me. and also to a very vocal minority of scientists who are supporting Dr. Levin's assertions. And by the way, that group of scientists is increasing in number by the year. So when is the paradigm shift going to take place? When the first visitors to Mars catch a Martian disease? I think that it would be very prudent for us to step up our efforts to find any microbial life, if it does indeed exist, and to take extreme decontamination procedures when we finally do send humans to the planet. Now, perhaps these Martian microbes, if they do exist, don't represent a threat to us at all. Perhaps they are completely innocuous. Sadly, we probably won't know that until we actually send humans into harm's way, because these robots can provide only so much information. And of course, if we send humans to actually find out these facts, we're sending humans into potential danger. And that may be the only way to rectify this situation. So, when we finally do send our first expedition to the Red Planet, we just need to remember that the things that we don't understand about this planet could be far, far more dangerous than the things we do. Now, I hope that throughout this video I've made it very clear that the reason that these mysterious dangers represent such a threat is simply because they are so mysterious. There's so many things that we still don't know, and we won't know until we're visiting this planet in the flesh, because we've sent robotic probes and orbiters, but there's only so much they can tell us. We know so much about Terran volcanism and Terran landslides and microbial life on our own planet, viral life, disease on our own planet, because we've been facing these things for decades, centuries even. But we haven't done that on Mars, and until we do, we're not going to fully understand both the wonders that it holds for us and the threats. So going there is a necessity, and there are going to be casualties along the way. But there's no other way around it. We have to go there. We have to respect this planet and the unknowns that it may hold for us, or suffer the consequences. But until we're confronting these dangers at close range, I urge all of you to stay angry about space.